digital piano.
Hi everyone, today I will be talking about a digital piano using 555 timer IC that produces six different musical notes. The push buttons control which note plays, and it only uses digital electronics and no microcontroller. It's powered by a 9-volt battery, sound output through 8 ohm speaker. Our key achievement is to demonstrate how frequency controls the different musical notes without a microcontroller or computer. The components we have used are a 555 timer IC, push button switches, 6 push button switches, 6 1K ohm resistors, one 4.7K ohm resistor, 200 nanofarad capacitor, one 10 microfarad capacitor, one 8 ohm speaker, one 9-volt battery, and one breadboard, and many jumper wires. A 555 timer IC is an integrated circuit that generates electrical pulses at controllable frequencies. It's one of the most famous and widely used ICs in the electronics, used in thousands of electronic devices for timing and frequency generation. It is used. The 555 IC has an internal oscillator that charges and discharges a capacitor. When the capacitor voltage rises, the output goes low. And similarly, when the capacitor voltage drops below a lower threshold, the output goes high. This creates a square wave output in pin number 3. The frequency of this square wave depends on a resistor and capacitor values. Finally, we have done this experiment in astable mode. The purpose of this is that the 555 IC continuously oscillates between high and low. No external trigger is needed. It keeps running on its own. Perfect for generating a continuous audio tone.
Hello, I'm Basit Hamid, and now I will explain the functions of this project and how each components work and how we are doing the whole thing. So now we'll discuss about the 555 pin functions, where and here this is the IC 555 IC which we used because it is a timer IC and it can create a lot of frequency in seconds and continuous frequencies. If we connect here the 4 number pin to the 7 number pin, like if we connect the reset pin with the VCC pin, then it doesn't reset and it turns in a continuous frequency mode. Our components are, here's the jumper wires, and here's the switches, push switches, and here's the 1K resistors. Here's the 1K resistors. This is also 1K resistor, 1K ohm resistor, and this is the 4.7K ohm resistor. Here's the 555 IC, the timer IC, which causes continuous frequency, and for the frequency, here the frequency when we press the switch 1 button, the pitch is so high because the resistance is so low, it's just 1K ohm. And here is the pin, switch number 5, here is the switch number 4, switch number 3, switch number 2, switch number 1. So what here happens is when we go upwards, the quantity of the resistance increases and the pitch gets lower, and here the pitch is higher because when resistance is low, the 555 IC timer can produce a lot of frequencies which makes the pitch high. And here when the resistance increases, the 555 IC timer lowers the frequency, so the pitch gets higher. So, and these are the jumper wires, so we can connect the switches to the 555 timer IC, and this is a 100 nanofarad capacitor, and this is a 10 microfarad capacitor. And here what we did is we connected the VCC to the positive side, and here we connected the ground to the negative side here, so everyone is the power in the same room. And this is how it works.
Now I will be talking why we have chosen this experiment and why we're using the 555 timer. It is reliable and a stable oscillator. It is easy to control, especially the frequency, with just resistors and capacitors. No microprocessor is required. It is widely available and inexpensive as well. Perfect for auto frequency generation from 20 Hz to 100 kilohertz. Why are we using astable mode? The main function for astable mode is that it produces a continuous oscillation without needing external trigger, produces consistent tone as long as the button is pressed, simpler than any other experiment. Why are we using button resistors? It is a simple way to change frequency without extra components. Each button shorts a resistor to the ground. Different resistance values means different frequencies, which equals to different notes. The advantages for this project is no microcontroller or computer is required. As I've mentioned before, only basic components, resistors, capacitors, ICs are required. Demonstrates real-world application of the 555 timer, shows how frequency relates to sound and music, proves you can make complex sounds with just a simple circuit. We have learned that how integrated circuits work, how frequency is generated and controlled, how resistor and capacitor values affect circuit behavior, how to build circuits on breadboards, how to debug and troubleshoot circuits, the relationship between frequency and musical pitch. Thank you very much.